Welcome to Theory Lesson 1, Unit 3.1, Pre-Flight Preparation, Basic Airworthiness. It is basic, but there are some advanced concepts in here. If you don't understand them, that's fine. You can ask your instructors, ask some aircraft inspectors, and they can help explain further. Every aircraft has placards that give us limitations to work within that are safe. One limitation is our weight. We have to fly at a minimum or a maximum, and we have a maximum all-up weight, which on this particular placard here we have 420 kilograms. And we also have a minimum pilot weight, which is 65 kilograms. This can also be adjusted down with the use of trim ballast or lumps of metal shoved attached to the nose of the glider on the inside or under the legs. And we have a maximum pilot weight. Unfortunately, most gliders do not allow flying for any humans that present at a greater weight than 110 kilograms. Here we have airspeed limits. Do not go faster than this speed. Do not go faster than this speed when the air is turbulent or rough. If you are going faster than this particular speed, then be gentle on the controls and do not use full control deflections. If you're on aero tow, do not go faster than this speed. And if you're doing a winch launch, do not go faster than this speed. If it looks like any of these speeds or maneuvering are going to be exceeded, then we have procedures to help you stay within those limits that are safe. Indicated airspeed is the speed shown on the indicator, and they're based on those limitations on the placard are based on indicated airspeed. But true airspeed is the speed that you're really traveling through the air, has to sometimes be adjusted for temperature and pressure because as we go higher, temperature decreases and so does air density. And the higher you are, the bigger the difference. We're not going high enough for this difference to be significant, but you need to be aware that this can occur so that you can refer to it later when you do get an opportunity to fly higher. Here is a maneuvering envelope. On the left-hand side here is load. A load of 1 is gravity. That's what you experience just walking on the ground. A load of 1.5 to 2 might be what you experience when you turn in an aircraft. Loads beyond 2 might be experienced when you're recovering from aerobatic maneuvers. Same with negative. That can also be when you encounter some air. And most limits here, you can see the limit is barely 1, almost not quite 2 negative G. And not beyond 4.5 G for this particular glider. At 1 G level, unaccelerated flight will give you this maneuvering within these speed ranges. So the speed here, maximum speed here, and minimum speed here on this line. The maximum speed can also extend out to the do not exceed limit, but it's caution, the caution area. Our goal is to stay in the green. Anything outside of that, you may have structural damage or failure. Failure means the aircraft will probably fall out of the sky. Structure will probably mean that you'll have to repair the aircraft if it manages to land. Here are some instruments that we'll be looking at. As I refer to the very first lecture that we had, lookout. The instrument of the canopy is more important than any other instrument because it's what your eyes see through. But we won't be talking about the canopy today. We'll be talking about inside the cockpit, of which we need to only spend about 10% of our time to check what we see outside. The first one is our altimeter. It is going to tell us how high we are. These little sublines here will give us an indication of the number of hundreds of feet where this here would be the big hand pointing to 6 and a bit, so it's 600 feet. And then these little lines are increments between 6 and 700 are 20 feet each. So this is 640 feet. The small hand, however, is pointing like a clock between the 3 and the 4. So it's not 4,000 feet, it's 3,000 and something feet. And the something that we worked out before is 3,640. This is also based on a level in the atmosphere, which can be adjusted using the knob. We usually set that at the elevation of the airfield before we take off, so that the reading is consistent with all other aircraft in the area, so that if someone says to you, I'm at 4,000 feet and you're at only 2,000 feet, you know that you're 2,000 feet apart from each other in terms of vertical separation. This is a diagram which you can look in the slideshow later at how an altimeter works. This static port is a hole on the outside of the aircraft that is just attached to a tube of air that feeds to the chamber that can adjust this diaphragm, that moves a spindle, that then, like a clock, moves the hands up and down to give us a reading. Question nil height is the airfield height. Question field height, if you put 0 if you're in the airfield, we don't use that here. And if you're flying very high, then we have an automatic setting so that everybody above this particular height of 10,000 feet adjusts the subscale for the pressure of 1,013.2 hectopascals. This is your airspeed indicator. It has a few markings on it, but the most important markings are the numbers and the big hand that's pointing to the numbers. This is showing a speed of approximately 52 knots. Green is inside the maneuvering envelope of green. Yellow is caution, red is don't go past. Go past there, you will cause damage. Do too much maneuvering in this area, you could cause damage. Everything in here should be safe. Below that is the stall speed, so this is showing a stall speed of just under 40 knots. This is showing an approach speed according to the manufacturer based on weight, but the GFA recommends 1.5 times the stall in calm air. So if this did have a stall speed of 40, if you add half of that to it, then your approach speed should be closer to 60. And of course, if it's windy, it will be even more. We'll give you some instructions on how to actually calculate that. But reading the numbers and reading some of these markings will help you in your initial stages of flight training. Here is a diagram of how an airspeed indicator works. You've got ram air coming in to a tube that's sticking out at the front of the aircraft or sometimes on the tailplane, and you've got static air coming in from the outside of the aircraft. These two air inputs move a diaphragm that moves some spindles that give us a hand position to give us airspeed based on this pressure. This is another instrument known as a variometer or a vario. Operating it is important. If you've got a thing here that's a mute, you can turn the sound on or off. You can turn the volume up or down. You've got some other buttons here, which you don't need to know about at this stage. But here's a needle. This 0 means that the glider is neither going up nor down in the air. You might be flying along, but this 0 means that you're not experiencing any lift or sink, which is pretty good. Using static pressure and a chamber or a bottle of air that adjusts over time. The needle can change as it measures the difference between these two, based on whether your pressure outside is decreasing or increasing. If the pressure is increasing, you are getting closer to the ground at a particular rate. So this might be a rate where each large dash is 2 knots and each little dash is 1 knot. So this is, if the needle was here, it might be saying you're going up a rate of 2 knots or approximately 200 feet per minute. It can be very mechanical or electrical. Some aircraft have both as a system of redundancy. Here's a compass. This is a ball compass. Some aircraft have card compasses, but either way they tell you which way you are headed. This glider is headed north. If you want to turn east though, from a north heading, you will turn right. You'll get more on this later in navigation and airspace. Other instruments can be attached to the glider, such as this personal digital assistant from the prehistoric era. Here's the vario. He's in a little bit of sync. Here is the altimeter. He's at can you even read this? Zeros at the bottom. 1,100 and something feet. Here's another vario, which looks like the mechanical, and this is the electrical. This is showing he's going down at the instantaneous rate of 2 and a bit knots. Here's his airspeed indicator, which is showing kilometers per hour. That's not very handy. We work in knots. Here's the compass showing his heading, which is showing that he is heading at 30 degrees of north, or just under. Red buttons on these, on the control columns, usually mean that's to operate the radio. This, which is obscured here, this one here is a flight navigation computer, probably linked to this one here, which is also a flight navigation computer. Here is another instrument called a FLAM, which is flight alarm. If a glider is fitted with a FLAM, it can see other gliders that are fitted with FLAMs, and they can have different displays. This is a radar type display. This one is an alert type display saying that in the high position, in your 4 o'clock position, could be a possible conflict. So in summary, basic airworthiness is about your placards, what limitations you can operate within based on speeds, all from the manufacturer's manoeuvring envelope. There are instruments that give us our height, our speed, the rate of change of height, what direction we're heading, some navigational aids, and collision warning assistance. If you have any questions, you can email us or ask your instructor at the airfield.